Okay, here we go. Cosine law. Cosine law, perfect. We just did the derivation, but I didn't record that part because I didn't want to, because it's super boring. But we did it. We did it together, YouTube. You don't get to see that part. So here's the law of cosines. There's three versions of this formula. Can you guys check your formula sheet? I believe you'll have one of these three. It's either this one, or this one. We still, I'll talk about that in a moment. We still name our triangle, like as far as the letters, the same as the sine law. Okay, so if you're going to call this angle A, the side opposite is little a. If you're going to call this angle B, the side opposite is little b. And if this is going to be angle C, the side opposite is little c. That's important because these formulas work with that assumption that you've named your triangle like that. Okay? And obviously you can change the letters and stuff, but that rule of if this is big A, that's little a, that's the one that matters. Okay? So you can rearrange this formula three different ways. And there is a pattern here, so let me show you. If you're going to have c squared on this side, the cos angle C needs to be here. And then it's going to be the other two sides squared, and then it's going to be minus 2ab. Look down here. If you're going to have a squared, then angle A goes inside the cos, and then it's the other two sides, so b and c squared, and then 2bc. Okay? Do you guys see the pattern to the formula? Because you only have one version of it on your formula sheet. Yeah? Everyone cool? All right, we're cool as ice. So there's really not a lot to do. I lost my eraser. There's not a lot to do as far as like we're just gonna practice using the formula. We might get like a wordy problem that makes use of it, but otherwise we just gotta be really good at setting up our triangle and popping in the right numbers in the right places, and then not messing up the execution, right? Like as you simplify down, because that's the biggest problem I see is people set it up and then they just have no work and they go to their final answer and it's like it's wrong. So you're gonna lose like half the marks, okay? Don't do that. You don't wanna lose half the marks. So right away, and I believe I've been kind of lazy today, I sort of pre-wrote them out a little bit. So we're gonna have some triangles and we're gonna calculate the length of BC to the nearest tenth. So let's see. There's our triangle. Now I've gone and I've labeled some things up here. So they've labeled the vertices, A, B, C. We know angle A, so I just wrote, okay, little a is this. Here's angle B, so there's little b, and here's angle C, so there's C. Now we are looking for side BC. Now for us, we're calling that little a, so I just put a question mark. And by the way, remember yesterday when I said, hey, like the order that you do, like that you try to solve questions with, like first you try using like the SOHCAHTOA stuff, right? Like the grade 10 stuff / like Pythagoras. So like, is there a 90-degree angle that we can see here? No. And remember, it has to be labeled or it has to be given in the question. If it looks 90, that's not good enough, okay? What's the next thing we would try? We would try, yeah, like sine law. Now for sine law in general, you need two sides and an angle. Right, so two sides and an angle, so this could be sine law, or you need two angles and a side. But the thing is for sine law to work, you need one complete ratio, right? Like angle C and side C. So we don't have that. We don't have that. We don't have that. If that's the case, then your only option is cosine law. Okay, so this is in order from quickest and easiest to longest and hardest of things you have in your toolbox. Yes, sir?
Could you use cosine law to figure out any, so you could use cosine law to figure out...
Yeah, like, so if you had a sine law question, you could probably use cosine law.
Same with 90-degree angles.
Yeah, like I did probably, yeah. Like, remember, cosine law is just, the Pythagorean theorem is just a special case of the cosine law that, like we were talking about before, okay? So I'm just trying to show you guys, like, yeah, in our notes, we know this is cosine law because we're doing the cosine law day in notes. But remember, on the test or in an assignment, like, you're just gonna get a question and it's gonna say, hey, solve this. So you're gonna have to go through this process. So do we all feel good about that? Yeah, it's really important because on tests sometimes I'll see people that the question's blank, and then after when I'm talking to the student, they're like, yeah, I just had no idea which one it was. Like I wasn't sure. You know, and then if I'm like, hey, it's cosine law, they're like, oh, okay, and then they can do it, right? So like it is a problem, like understanding like which one is it, okay? So I wrote my cosine law. And because I was solving for a, I wrote the one that has a squared, and then it's the other two sides squared minus 2, these two things, BC, and then cos a. And I'm going to pop in the information I have. So if there's a lot of writing today, I sort of pre-did that. So B is 15, C is 19, and then 2 times 15 times 19, and then angle A was 44, so cos 44. I will just give you a moment. I'll do my waiting dance. You guys let me know. I'm going to be really tired.
We're done, right?
Yes, sir. Yeah, if you must. Okay, I really want you to show me this step. Like, don't skip this step. I don't know how you would do the question otherwise. So some people are tempted to just type it all in on their calculator and get to the answer. You could. It's risky. Like if you make a mistake, like you're gonna lose like a mark or something. Depends on how many marks the question is. What I recommend that you do. So if you look at my next step, there's actually 2 steps in this step. So the 15 squared plus the 19 squared, that's 586. So I recommend that you actually do that on your calculator and then write that number down. And then because we have all the numbers here, I did 2 times 15 times 19 times cos 44, and that's what I got. And always keep at least 1 decimal more than what they're asking you to round to. So if it's the nearest 10th, I just kept 3. If you keep 4, your answer is still going to round to the same thing, but you got to keep at least 2, okay? You got to keep 1 more than what you're rounding to. All right, and then I did the next step where, well, I'm going to go this minus this, and then to get rid of the squared on the a squared, I got to square root both sides. So I'm going to do the square root of whatever I get here, and that's going to be my final answer.
So why do you square root with
Well, how do you get rid of a squared? Got a square root, right? So we square root both sides.
But why do we need to keep 2?
Why do I need to keep?
Yeah, can we just 586?
I'm just not sure what you what are you referring to?
Why do you have the squared when it's in the bracket square root?
Oh yeah. So I did this step and then I square rooted.
Oh.
Yeah, I did 2 steps in one. Yeah, sorry about that. Yeah. Yeah, and I didn't want my notes to get too messy, so I didn't want to like cross off the 2 with the square root or anything. I didn't want it to get too messy, so I just left it like that. Yeah, that's a good point. So is everybody getting this? I really recommend that you're trying on your calculator as we go. Right, you want to make sure that you know how your calculator works. Everyone's good? Yeah? Yeah, hello, wall, ceiling, is everyone okay? Good, okay. You guys are just staring at me, you know? Here's another one. Now, yeah, this is the try it yourself, but let's do it together. It looks easy, but it's actually quite tricky on your own. So they just gave us this one, and remember, they just said you're finding side BC. So it's the same exact setup. We're looking for side A, completely different triangle. And when I'm looking through, I'm like, okay, there's no 90 degree, so I can't use Pythagoras or I can't use SOHCAHTOA. For sine law, I need to have 1 complete ratio. So don't have the other side. I don't have angle C. Oh, I don't have angle B. I must use cosine law. Okay? Yes, sir.
I'm getting a math error.
A math error over the previous one? I'll have to come look after. Yeah. It will be something you're typing in or something. Yeah. So I wrote just my formula, which I recommend you do. Right? Because you got to figure out which one is it. So if you're looking for the a squared, then it'll be cos A, and then the other 2 sides squared minus 2 BC. And then plug in your numbers. So it looks something like this. Oh, I circled the negative sign for a reason. We'll see on the next step. Should I do my waiting dance?
Sure.
Oh, you guys like the waiting dance? You guys let me know.
We're not allowed to stop.
I usually stop after a few seconds. Was I not on camera?
You weren't on camera.
Perfect. I was actually worried about being on camera. When am I on the camera? Here?
Yeah.
Oh, yeah.
Oh yeah, it's basically sized to the screen, so okay. Sorry, I hate this, the fact that we're using this projector down here, so hopefully they get us a new one soon. That was boss though, how we made it so big.
I mean, Miss Brawley just got a new smartboard and it's a new generation, so
New generation
it's a
smartboard.
newer one, so.
Miss Brown, these English teachers. Who was getting all the funding, and us math people just have to get along with our cards from the 1970s.
It's classic.
For the YouTube people, we live in Canada and we're using an old repurposed overhead projector. Yeah, this is not like one of those LED projectors. It's do you guys even know what an overhead projector is? Did you guys have them when you were in like elementary school?
Oh yeah.
You did?
I think. No.
I'm surprised you guys did. When I was in high school, like, they were getting phased out pretty quick. Anyways, so we have all that stuff there. The reason I circled that negative is on the next step. So, we got 666. So the 15 squared and the 21 squared, that's where I got the 666. Now, I chose to just show what happens. When you type in cos 144, you're in which quadrant if you've done 144 degrees rotation? Quadrant 2, and cos is x. Is x positive or negative? Negative. So this ends up being negative, right? So now you have this negative from out here, and cos 144 gives you a negative. So you have 666 subtract negative 509.68. So when you go this times this times this times 2 with your calculator, you will get negative 509.68. Can you double check? Just make sure. Yeah? So we have a double negative, so we're going to end up adding those, which we shall do. I didn't show that step. Okay, so I just did 666 plus that, and then I did the square root of it. You'll notice in this example, I thought ahead, and I did the square root and got rid of the squared here, so that's another thing I did. And you get 34.3. Don't forget your units. Is everybody happy with that? Excellent. I see some writing, so I'll just wait. If I was really good, I would edit this out of my video, but it just takes too long. So I will keep going. Alright, another one. Now this one, I'm just going to erase the thing I drew here. This one, they haven't given us a picture, so we'll practice drawing it again. They just say, oh, I got a triangle, DEF, and they give us a bunch of info. Determine the measure of angle F. So a couple things. We're using the cosine law to find the measure of an angle, which is a little bit trickier, and we have to draw the triangle. So in those cases, I really just recommend that you do your best to sketch some kind of triangle. Now mine always end up sort of looking like they're isosceles triangles. I'm going to try to not make it. And like again, I know that looks like a 90 degrees. It's not supposed to be. So somewhere start labeling it. So there's DEF. Right, so label it clockwise or go counterclockwise, it doesn't matter as long as you label it, and then the opposite side of D is little d, the opposite side to F is little f, the opposite side to E is little e, there. And then I read my question again, it says DF is 18, so DF, that's talking about the big letters, we call that E, so E is 18, and DE, so again, it's looking at the vertices, the big letters. DE is 12, but we call that F. And EF, sounds like a donkey. That's 10. How do I get anything done with all these voices in my head? Only Muhammad laughed. Some of you are smiling. All right. Well, hey, we got all the sides, and we're looking for this angle. And we don't know anything else. So let's do a check. Like, is it a 90-degree triangle? Can we use regular trig? No. I mean, that sure looks like it's 90, but that's because I can't draw. So yeah, all right. So we don't know about that. Sine law, well, you need a complete ratio, and you don't have a single angle, so you'll never have a complete ratio. So therefore, I must use cosine law. Okay? So, start by writing your cosine law. Now, which one are we going to use? Like, which side squared is going to be on the left? E, F, or D? For looking for angle F. Very good. So it's going to be F squared. Okay? Let's see if you guys can come up with it before I unveil it. So if it's F squared, then it's like, okay, so it's F squared is the other two sides squared. So E squared plus D squared minus 2, whatever you got here, so 2ED times cos And then you look over here and it's always cos of whatever letter that is. Now I may have written it in a different order when I view it here, but it'll be the same thing. Oh, we're lucky, it's exactly the same. Now we're trying to solve for cos f. So you could like be fancy and rearrange the whole formula, like you could solve for cos f. In the past I found that that's sort of tricky for students. So what I generally say now is like, all right, well, plug in the numbers that you know and then start solving, okay? So that's what we're gonna do, I believe, if I remember how I did this, yes. So I just went ahead and I said, all right, I plugged in the value for f, which is 12, I plugged in the value for e, which was 18, the value for d, which is 10, and then I did subtract 2 times e times d, and then I left the cos f because I don't know what that is. Now you're gonna clean this up, right? Like you can type that in on your calculator, you can go 2 times 18 times 10 in your calculator. So let's give you a moment. Can you guys see that my bow tie sparkles? You guys always treat me like my grandpa does, where I'm like, hey grandpa, look at this, and he's like, you got it. You're doing something there. I'm gonna go now.
We just really love our mathematical equations.
Okay, I'm gonna unveil the next step and just talk through it a little bit. So there it is. Ah, yes. So that's why I'm gonna write that part. So all right. Just gonna scroll as far up as I can. I'm just writing on the board here. So there we are. So when you go 18 squared and 10 squared, you get 424. When you go this times this times this, you get 360, and there's a negative there, and 12 squared is 144. So now you're just trying to solve this equation, you're trying to isolate this. So for all intents and purposes, you can treat this like an x, right? So my first step will be getting rid of the constant term, right? You guys agree? So I'm going to subtract 424 from both sides. So that's why I had that. So I subtract 424 on that side, I subtract 424 on this side. That'll be gone, and then I get, when you go 144 minus, a little crooked there, when you go 144 minus negative 424, you get negative 280, agreed? And then you just have subtract 360 cos f. How do you get rid of the coefficient? You divide by negative 360 on both sides, so you can see that's what I'm doing. It's sort of writing crooked, so it's not quite covering it all the way. So on this side, negative 360 divided by negative 360, well, that will divide out to positive 1, and I just have cos f. Over here, you can get rid of the negatives, so you got a negative on the top and on the bottom. So I just have 280 over 360 equals cos f. Now how do you find the angle? $1 million question. Because you got a ratio. You don't even have to waste time reducing it. Like you could cross off the zeros, whatever, but who cares? How do you solve? What you gotta do, you gotta go, starts with an I, inverse cos. Okay? So you're gonna go inverse cos of that ratio. I'm just gonna scroll up a little bit. There it is. So I wrote angle F equals inverse cos of that ratio, popped it in on a calculator, you'll get 39. Do we all agree? Excellent.
Can you leave it up?
Yes, certainly, yeah. I'll do my waiting dance. I'm on camera this time. That's as long as I wait for. The rhythm demands that we go on. Is everybody ready?
No.
No? Okay. What was I want on YouTube? I wanted, people could pause.
Yeah, I could just scrub through.
Okay, I'll just start erasing. Alright. I can always go back. Because now we have to do a big word attack problem. These are the worst. Oh, this question is a nightmare. So I'll give you a moment. Just to read it. I'll be back in like 10 seconds. You can quote me on it. Starting like now. Oh, I remember we had a huge debate about this like last year. This one sucks. So it's a, and there's an easy way to do it and sort of a trickier way to do it. So yeah. You definitely got to draw a picture. So we got rectangular array of solar panels that are 10 by 20, and those are to be installed on a flat roof of a factory in Alberta. I love how this textbook like tries to bring in like the different provinces. The angle of inclination of the array should match the latitude of Lethbridge, which is 49 degrees. This is like a real thing. Like when they install solar panels, like the one thing they can do to like help increase the efficiency is have that angle of inclination match the latitude, because then the sun, I don't remember, the sun shines on it in a way that's better. Yeah, I'll just leave it at that. I read that there's like a dude somewhere who like is making a thing that like slowly adjusts, like as the sun moves through the sky, adjusts the angle or something, so you get like maximum sunlight all the time. But anyway, there's a problem for someone to solve to make that cheap. Anyways, the array is supported in position with its 20-meter side horizontal. The cross section of the support in the panels forms a triangle with a base that is 15 meters long. So it's like, imagine like I'm standing here and I'm on this roof, and as I'm looking at the solar panels from the side, that's what the cross section is. Okay, so what they're trying to say is that the cross section is sort of like a triangle. So it's like something like this, right? So it's like on one side you'll have your panel, right, and your angle of inclination. And I'm just going off the picture I drew before, so I don't want to make a mistake. Your angle, so this is like the actual roof. I'll write that inside. Right, like that's the base of the roof. So you got this triangle, and then this would be like a support, right, to keep that thing so it doesn't fall down. Yeah, is that clear? Basin? Am I painting a nice picture here? Good. Okay. So what do we know about this side? Do we know how long that side is? It says it's 20 meter side is positioned to the horizontal. So like that was the part we had a huge debate about last time we did this. So these panels are rectangles that we're gonna put on top of this, right? And the debate was, so is it 10 meters this way or 20 meters? Like, you know, the horizontal would be, in my mind, the horizontal would be coming out at you like this, right? Right, so this is 20 meters. So as far as we need, this should be 10 meters. So this would be the side of the panel that's 10 meters long, and then it's gonna be 20 meters this way, and you're gonna have these big triangle things that are holding them up. It really helps. I should show you a video of them installing solar panels, because sometimes there's a field. There's a farmer somewhere not too far from Brandon that literally has this set up like on his field. Yeah.
That's my neighbor.
Oh, really? Okay. Oh, yeah, I think it is. Yeah, it is going out towards your place. Yeah. Well, there you go. That might help you visualize it better. All right, so the cross section of the support forms a panel, forms a triangle with a base that's 15 meters long. So which side was the base again? Where's the roof? The bottom? Yeah, so this down here, this was the roof, so that's the base, so that's 15 meters long. For this cross section, determine the measures of the other two angles to the nearest degree and the length of the third support. So basically they're asking us for everything. They're like, how big is this angle? How big is that angle? And how big is that side? So it's one of those classic, like, solve every piece of this triangle problem. Okay, so we can't use Pythagoras or regular trig because we don't have a 90-degree angle. We don't have a complete ratio either. So we don't know an angle and its corresponding side, which means that at least for the first step, we're going to have to use cosine law. Yeah. So we also don't have letters here, so let's label it up. And I'm just going to go with the same thing that I had. So I labeled it like this when I did it before. So I just did ABC. So that would make 15 little a. And this side here that we don't know is little c, and then this side that's 10 is little b. Now I need some room to work, so I'm actually going to just delete that. There we go. And I'll do some work over there. So what should we find first? What can we find first?
You can find C.
Little c, right? Why? Because to use cosine law, if we don't know the side, we need to know the angle, and then we need the two other sides. So that's the only thing we can do right off the hop. So we'll do that over here. So we're going to go c squared equals a squared plus b squared minus 2ab cos c. And then I like to double check. This matches that. That's the other two sides. It would be negative 2 AB. That looks good. Now I'm going to pop in the numbers I know, which is nothing. Just kidding. We know A. A was 15. So I go 15 squared plus 10 squared minus 2 times 15 times 10 times cos, and what's angle C? 49? Great. And now that I just need to pop into my calculator. So again, I recommend you take it in tiny baby steps. 15 squared is 225. 10 squared is 100. So you get 325 there. You double check on your calculator, double check on my work. Yeah. And then 10 times 15 is 150 times 2 is 300. So you got 300 times cos 49. So I'll just write that for a second. You type that in on your calculator, and what would you get? Anybody? Anybody?
197 rounded.
Okay, yeah, and I don't think it says anything about rounding. I'm just going to keep a couple decimals until I get to my final answer. But you're right, you would round to 197. Okay, and now you are basically going to square root both sides. So you're going to get C equals, and now I got 11.32. And I think our units were meters. Or if we just round, I guess we would say 11 meters. I don't remember if it says in the question what to round to. It says the nearest tenth. It says the nearest tenth. So let's actually get rid of all that. And you're going to round to 11.3 meters. How's that? Yeah. Now, I worked with a couple of carpenters back in the day. And like this would be something that a carpenter like would do. Like they would mock this up and they would get the angles and they'd figure out like the lengths of all the pieces they need to cut. It's definitely, so like if you're kind of curious like, oh, where does math get used? Like this is totally something a carpenter would do. If it starts getting a lot more complicated, I got a lot of buddies who are engineers, and it's like, yeah, so we'll do the calculations, and then some guy who works with metal will like go and cut them, and then if there's like a welder involved, the welder will go look at it and like make sure everything's good and weld it. And then you got your grunt guys who like carry the heavy stuff and put it in place. Yeah, it's like this huge team effort. It's kind of neat actually. I was impressed when I worked with the carpenter to build like a 700 square foot deck in my house, and I was like, can you just teach me? Like, I'll just pay you more and I'll just learn. And he's like, yeah. And he like the way that he calculated, like if this thing was straight, it was tons of math. I was like standing there and I was like, I'm not telling him I'm a math teacher. It was like that stuff he did. I was like, wow, like that was complicated. I'm not sure if I immediately grasped like how it worked, you know? And it's just like, well, he does it every day and like he does very specific things. It was really neat. It's very humbling. Okay, so there's that. And what else do we want to calculate? What do you want to do next? We now know that this is 11.3.
We could calculate one of the degrees.
So then what are we going to use to calculate one of the angles? Sine law. And you have options, right? Like you're going to use this as your entire ratio. So I'm just going to go like this and say, okay, well, I'm going to go sine C over C equals, which one do you guys want to do? A, perfect. So we'll go sine A over A. So we know sine C is sine 49, and we know that side C is 11.3, and then for sine A, well, that's what we're looking for, but length A is 15. Okay, now, just like yesterday, if you set it up like this with the thing you're looking for on the top, you just got to multiply both sides by 15. So you're going to go sine 49 over 11.3 times 15, and that will be sine A. So you could pop that in on your calculator. And I think I did a completely different one. So I guess we'll have to see. And I think, rounding causes a big issue in this problem, so hopefully we don't get stuck in that. But let's see. Someone let me know what you get when you go sine 49 divided by 11.3 and then times 15. We'll get some confirmation. Anyone? Exactly one, yeah. So you get like 90 degrees or something. It's because of the rounding. We rounded. I remember this happened last time too. If you keep enough decimals, I wish we hadn't chosen angle ICU. If you keep enough decimals, you'll end up getting 89. Like this is almost a 90-degree triangle. It ends up working out. Yeah. 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 What did you get for angle B? Like 42. Yeah. So if you round to 11.3, like this will basically you said it works out to exactly what? Or is it like 0.99999?
1.0018.
Yeah. So as we rounded, you end up getting like 1.00. Yeah. Which then like, well, what would that be? Like that would have to be a 90-degree angle, right? We know that. We know that. What's inverse sine of 1? Where is sine equal to 1 on the unit circle?
2 degrees.
Right here at 90 degrees. So A would be 90 degrees. And it's like, oh, we could have used Pythagoras. And hey, like, this very well could have been a 90-degree triangle. We just don't know. So I guess let that be a lesson to you. It's like, yeah. Remember when I said there's an easier way? The easier way is like, there's actually a way of figuring out that this is 90 before you start the problem. But I didn't do it that way. I wanted to do it the hard way. But it actually only happened because we rounded. If you don't round, you get like 0.99999. Okay? So I'm just going to point that out. But yeah, so you get that. Let's do sine law for B. Okay? Although at this point, we could go this, 180 minus that and that to get that. But just for practice, we'll use sine law. And let's use, I guess, C. Yeah, this question is just a nightmare last year. So sine B is what we don't know. We know sine B is 10, and that sine C is sine 49 over 11.3. And then we'll end the video there. We won't do the last problem. That's enough. Yo, man. Sorry? Okay. So when I do all that, I got that this is 0.6679. Right? So we'll go inverse sine of 0.6679. And when you do that, you get 42. You get 41.9. You get 42 degrees. So if you were to go calculate A, like the other way to do it is you go angle A is 180 minus 42 minus 49, which is going to give you 82, is it 91? Right? So you get 91. So then you get that angle A is like 89 degrees. Right? But then you're like, oh, but over here we got 90. Well, depending which side you solve for first, once we've rounded this, yeah. So the numbers are so tight that when you round it, you sort of actually change it. It's not actually exactly 90 degrees, I don't think. Okay, but are we okay? I'll make sure that if we have something like this on the test, it's not going to work out that way because it's sort of confusing. But I guess it shows you how messy like real world calculations can be.
Oh, Darren.
I told you guys about how they lost the satellite back in the 70s because of a rounding error. Yeah. This is why. Like when numbers get really, really, really big, like distances in space are huge. When you have a rounding error, that means like, oh, you just missed it by like 30,000 kilometers. But it's like a tiny little rounding error.